Hello everyone. In our last video, we seen how to deploy a machine learning model in EC2 server, and also we exposed that machine learning model as an REST API, right? In this video, what we'll do is, so whenever the file that wheat file that is uploaded in S3, right? So our Lambda will be triggered. As soon as the Lambda is triggered, we'll read that file which is present in S3, and we'll get the required information from that particular file, and then that data will pass it to our REST API, the machine learning model which we deployed in EC2 server. And whatever the response which we will get from that machine learning model via REST API, that particular message will store in SQS, which is nothing but simple queuing service. It is one of the services from AWS. By now you might get, right? So in this video, we'll be seeing lambdas and queues, which is nothing but we'll be using lambdas and queues, right? First, we'll try to understand what is lambdas. So lambdas are the event driven serverless computing platform. So whenever you say event driven, right? So as I said, whenever the file comes in S3, our lambda will be triggered. That's an event, right? So the uploading a file in S3 is an event, right? Writing a file in S3 is an event. Whenever the particular event triggered happened, our lambda will be triggered automatically, right? That's why I'm calling it as event driven. So when I say serverless, I'm literally not worried about any of the servers. I need not to worry about starting EC2 server, installing Python, this, no worries at all, right? In simple, right, where you can write and run your code without thinking about the servers, right? So this is the Lambda home screen, so you can create a function here, right? And yeah, so you can give some meaningful name, and here this is the programming language. It's suppose .NET, Go, Java, Node.js, Python, Ruby, right? And yeah, so I'm just selecting Python 3.7, and obviously this particular lambda, right? So as per our current requirement, this particular lambda need to read the data from S3 and write the data into SQS, the prediction data into the SQS, right? Which means our lambda needs some permission, right? So our lambda should have access or permission to read or write the data in S3 and SQS, right? And that's where this permission belongs to, right? And also the best part about the lambda is, right, so obviously when you're running your lambda, or you're testing your lambda, or your lambda is in the production, whatever, so you need to know what is happening behind the screens, right, which is nothing but the logs. So in AWS there is a service called CloudWatch logs. Here you can check the logs for lambdas, SQS, EC2, whatever, right? So this is the common repository where you can check the logs across the AWS services, right? So our lambda should also have an access for CloudWatch, right? So we have to create the role, right, or permission where our lambda can access it. So I already created a role, so I can use the existing role, or you can say create a new role from AWS service, or you can create the role with the basic lambda permissions, which means it will have access to writing the logs into CloudWatch, right? You can attach the templates right over here, right? Let me show you, right? So now I'll give some meaningful role. Now what kind of permission that this lambda should have? I say this AWS object read only permission, right? It will read, and then I can type SQS, right? It can talk to SQS, right? Like that you can define different roles where your lambda need to talk, right? So now I can say create function. It's creating a function. Yeah, it's loading up now. Okay, it's still loading. Yeah, so you'll get a window here. That's a place where we'll write our the code, whatever the programming language which we selected, right? So you can write your logic and whatever, right? You can create your environment variables here, and also you can set what is the RAM required for this, particular lambda, right? You can set RAM up to 3 GB, and you can have the execution time up to 15, right? 15 minutes, So the time mode will be 15 minutes. So if you get any data where it will take somewhere around 13 to 14 minutes to process the data, so you can set the time accordingly. In our case, it will hardly take seconds, right? And we don't even need such a huge RAM. We are just processing the bytes of the data, right? Not even kilobytes, right? And there the many properties which are available. And the very important point that we need to remember when you talk about uh, the lambdas is, especially when you talk about Python, right? So whenever you install a Python, obviously you won't get pandas, numpy, sklearn, right? Those are the packages which we are installing using pip, right? So when you talk about lambda, it will have only the packages that comes with Python, that comes with the Python installation. You won't have pandas, you won't have numpy, you won't have sklearn, whatever, right? Whatever you're installing with the pip, pip3, you won't have those packages available in lambda, right? So what we need to do is, so there is a way where you can build your pandas package in Linux server, and you can import in the layers. That's what the layers concept is. And also you can see here, right? So we have add ticker and add trigger and add destination, which means like this lambda should be called by someone else, right? And that's for the trigger. So now in our case, our trigger point is S3. You can API gateway, which is nothing but you can expose your lambda as a REST API. So aid IoT. So your IoT devices can talk to lambda, the Alexa skill set. So whatever you name, right? So you can talk S3. Whenever the file comes in S3, this lambda will be triggered. You can mention the bucket name here, right? And whenever the object is created or deleted, you can mention the prefix, suffix, so whatnot, right? So this is very basic about the lambda. Now let's get into the code. So I already had the code, right? And I already created the trigger here. So here, as we know, right? So, and very important thing which we need to remember is, so this is the lambda handle, which is nothing but your main function. This event is a variable where you'll have all the data. Whenever whoever is calling the lambda, they'll be sending data to the event, right? And so now we know, right, that whenever the file is uploaded in S3, right, we'll get the required information in the variable called event. We'll get information something like it. This is a standard, what you call request. Whenever the file comes, it's a dictionary, right? So you'll get lots of information, right? So what we mainly worried about is the bucket name and the file name, right? So which you'll find in S3. Yeah, this is our bucket name, and this is our key name, which is nothing but our file name, right? Which we are trying to read it. Let me show you here. Yeah. So here now we are using Boto3. We know what is Boto3. So now we created resource that connects to S3. Now I'm saying S3 object. This is my bucket name, right? And in the events records on the 0th occurrence, we are just getting the key name. We are not, technically speaking, we are not supposed to hard code this bucket name. We can also obviously take it from this event, but yeah, I'm just hard coded. So now we are getting, so we know we are storing the file as an JSON format, which we already seen, right? So which has uname, data, and the Twitter ID. Let me see if I opened it. Yeah, I already have it. Did you see? We have uname, ID, and the data, the actual content, right? So now actually when it's a dictionary, technically when you talk about JSON, it's a dictionary. So when we are reading this particular data, it will be read as a string, right? So whenever you're reading a list, tuple, dictionary as a string, right, so we have to convert it back to the normal form. So this is the AST is one of the default Python package that has a method called literal eval. So what it does is it will convert your the string into the actual format, like it can be a list, tuple, or dictionary, right? So now in the data we'll have the required information. So in the data, I'm getting get is an object to get the data, right? Like somewhere, something like when you're reading a file, right? What you'll do, you'll say data.read, which means it will read the file, stream data, right? And then inside that you'll have a body where I'm reading it, and then I'm decoding it to the UTF-8 format, right? So which I'm printing the content, right? Because obviously we just need only the data, right? So to pass to our machine learning model. So the reason we have one of the best package called request in Python, where it is really nice and easy to use package to call any other REST APIs. But unfortunately, as I told you, the lambdas will support only the default package. So URL is the default package that comes with the Python installation, right? And I'm saying url-lib.request of request. This is my URL. This is my REST API URL, which I deployed in our EC2 server. And this is the tweet. I'm just encoding it. The problem with the URL lib is you cannot send string. You can send only bytes. Other than bytes, you can't send anything. That's why I'm encoding it here, right? And my header type is my headers, right? We have content type is plain and text. And now I'm just creating a connection with the help of this request object which we just created here, which has URL, the data and the header type, right? And then I'm triggering it, and then I'm getting the data here. Now the important, the major part is done. We are calling a machine learning model and we are getting the response. As per our design, as soon as we get the response, that response has to be uploaded into SQS, so that there will be other lambda that will always pull this SQS and will read it. Now, before we talk about SQS, we know what is SQS, simple queue service. First, we'll try to understand what is queue and topic. This is one of the important thing to understand, right? So typically this queue and topics, they fall under MOM, which is nothing but message oriented middleware, which helps to achieve interoperability, which means that will help us to communicate with different systems with very minimum changes. For example, when I want to send a message to other systems where that particular system is not compatible with the system where I am trying to send the data, right? In that case, I can put message in a queue where the other systems can read the data from the queue and process it. Maybe for example, something like this, right? I'm trying to reach my friend where he is not available. So what I can do, I'll simply put a message, right? Maybe we can say that, right? And the other benefit is loose coupling. We just discussed, right? So now I need not to wait for my friend. So I call my friend and he's not picking the call, right? So I need not to wait for him to call back to explain him what happened, right? I can simply message him, and whenever he's back, he'll okay, look into the message. Okay, this is the thing happened. So he'll take whatever actions he want, right? That's how in real time, right? So that's where we can achieve the loose coupling, right? So what I can do, I can simply put the message in a queue, right? So whenever the system wants it or whenever the system is up and running, it will come to the queue and read the data and process it, right? So SQS falls under message oriented middleware, right? Now here you can create a topic. You can give some it's very straightforward. You can give the meaningful name, and you can tell how many seconds that this seconds or minutes that this data can visible, right? There are few other properties, right? So which we are not worried for now. So I already created a queue which is called tweet predict and this is the URL for this particular queue. So when you want to send the data or receive the data, you'll be using this particular URL, right? And that's what we are using here, if you see, right? And of course I again use Boto3 where I create an object for SQS. Sending a message is very simple. Send message and your query URL and your message body, right? So here we should be able to see the messages in the monitoring, not in the monitoring. Yeah, maybe the subscriptions. Yes, not even in subscription. It should be send and receive message. Yeah. Pool for message. We have two messages. Let me delete those messages, right? Now we know the requirement, right? As soon as the file is uploaded in S3, our Lambda will get triggered. So we'll see, this is the logs for the particular Lambda. How you can navigate is, you can go to monitoring, you can click on view logs in CloudWatch. You'll get this screen. Let me delete the existing logs. Now I upload the file in S3. I already have a file. Let me see if my REST API is up and running. Yeah, I'll just say upload. We are anyways printing here so that we can see. Yeah, so it says that particular tweet is positive. Now by now we should be able to see the message here. Oh yeah, you can see the body here. Yeah, it's a positive, right? So now I'm able to successfully upload put the message in the queue. You can also see the Lambda logs here. So whatever we are what are the steps we are performing in the Lambda, you can see it. If we have any success messages, error messages, right, you can see everything here, right? So here I am printing the event. If you see here, it's just still loading. Come on, right? So here we are printing the event, we are printing the file, the content which has only data, right? We are printing the response of the SQS, right? It says 200 is success. Obviously we are able to see the message in the queue, right? So hope you enjoyed this video. In the next video, what we'll do is we'll create one more Lambda that will always pool this particular SQS. Whenever the data comes into the SQS, that Lambda will be triggered. If it is positive, we'll tweet accordingly. If it is negative, we'll tweet with comment, retweet with comment accordingly. At the same time, we'll store all the data into our database, right? So till then, please don't forget to subscribe to my channel. Thank you.